In this lesson, we'll discuss powering of our data centers. Now, data centers are the beating heart of our digital world, and keeping them powered under all circumstances is crucial for the success of our business operations. To ensure our data centers always have power available, we must architect our infrastructure with multiple forms of redundant power. Now, when it comes to power, there are 5 key terms that describe the current state of the power being received by our systems. These conditions include things like surges, spikes, sags, undervoltage events, and full power loss events. First, we have a surge. Now, a surge in electrical power means that there is a small and unexpected increase in the amount of voltage that's being provided. So, here in the United States, our default power supply uses 120 volts. Now, if that went up to 125 or 130 volts instead of remaining at 120 volts, we would call this a slight increase in the amount of power being received as a surge. Second, we have a spike. Now, a spike is a short transient voltage that's usually going to be caused by a short circuit, a tripped circuit breaker, a power outage, or a lightning strike. With a spike, you might see a default voltage of 120 volts rise all the way up to 150 volts or 175 volts or even more. To protect against a surge or a spike, your system should utilize a surge protector or line conditioner, which will be able to remove any power levels that are higher than about 120 volts that are used by default here in the United States. Third, we have a sag. Now, a sag in electrical power means that there is a small and unexpected decrease in the amount of voltage that's being provided. A sag is very similar to a surge, but it's actually an opposite, because instead of the voltage going up, it's actually going down. Usually, a sag will only occur for a short period of time, and if the decreased voltage remains fairly close to your default level of 120 volts, then your computers may not even lose power or go offline during that sag. For example, it's common to see sags drop the voltage from 120 volts down to 117 or 115 volts instead. And at these levels, your computers will remain online and operational because there's still enough power to run them. But it could damage your hardware components over time, and so again, you want to use something like a line conditioner to bring that voltage back up to the 120 volts that you're expecting to get by your systems. Fourth, we have an undervoltage event. Now, an undervoltage event, which used to be referred to as a brownout, occurs when the voltage is reduced to lower levels, and it usually occurs for a longer period of time. For example, if you're expecting to receive 120 volts of power, but the voltage level drops down to 70 or 80 volts instead, this would be considered an undervoltage event. In this case, the voltage will be too low to continue operating your systems, so your systems will go offline and power themselves down. Fifth, we have a power loss event. Now, a power loss event, also called a power failure, or referred to by its legacy name of a blackout, will occur whenever there's a total loss of power for a given period of time. For example, if you're sitting in your home office and the power is completely lost for a minute or two, that would be considered a complete power loss event. With a complete power loss event, it's really important that you're aware that when the power is restored, it can actually cause a power spike to occur, and this can damage your systems too. So, now that you have a good understanding of the 5 different power conditions that you may experience, including surges, spikes, sags, undervoltage events, and full loss of power events, let's take a look at the different types of robust systems that can help us to keep our data centers up and running by focusing on line conditioners, uninterruptible power supply systems, generators, and power distribution centers to better understand how these components help to ensure the high availability and reliability of our systems located within our data centers. Now, first, we have a line conditioner. A line conditioner is used to overcome any minor fluctuations in the power being received by the given system. A line conditioner is going to be used to continue powering your systems with clean power, even in the face of a surge, a sag, or even a more pronounced undervoltage event. Without a line conditioner, these types of power conditions could cause unexpected system behavior or the degradation of your hardware over time. But by using a line conditioner, we can automatically adjust the power signal being received as an undervoltage or overvoltage condition, and then change it back to the standard power level of our systems that they're expecting to receive in order to prevent damaging our systems or their associated hardware. A line conditioner is a great addition to your systems, but they're not going to keep your systems running if you're experiencing a significant undervoltage event or a complete power failure event. Second, we have an uninterruptible power supply. Now, an uninterruptible power supply, also called a UPS, is a device that provides emergency power to a system when the normal input power source has failed. A UPS also provides line conditioner functions on your behalf, as well as providing a battery backup to maintain a consistent power level to your systems, even when a complete power failure of the power source has occurred. While a UPS is a great device to use in your architecture to ensure your systems can remain online at all times, it is important to remember that most UPS units will only provide 15 to 60 minutes of power during a complete power failure. So, These UPS units are really designed to help prevent data loss or hardware damage during a sudden or short duration power loss event, and not going to be something that's going to help you for the long-term power outages. So this brings us to our third thing, which is known as a generator. A generator is a machine that converts mechanical energy into electrical energy for use in an external circuit through the process of electromagnetic induction. Now, a backup generator should be installed as part of your emergency power system architecture so that when there's an outage of your regular power supply for the electric grid, the generator will be able to take over and provide power to your devices for an extended period of time. Now, some smaller generators can provide just enough power for things like emergency lighting, while larger commercial backup generators can actually power your entire building or at least large portions of your building and its systems. Generators are going to come in three main varieties: portable gas engine generators, permanently installed generators, and battery inverter generators. Now, a portable gas engine generator is the least expensive type to operate because it usually uses just a small gasoline engine to convert the mechanical motion into electrical power. These generators tend to be smaller and more portable, but they also can't support providing high levels of power either, so they can't be used to power an entire building like a large generator would. With a portable gas engine generator, you're going to find that they tend to be very noisy when they're operating because of that gas engine being used, and this also means they require higher levels of maintenance because they're using a gas-based engine. These generators are usually carried to the location where they're going to be needed. Then the device that requires power is going to be connected to the generator using an extension cord, and finally the generator is manually started up and run to provide that power. So you're probably not going to be using a portable gas generator for a large server room, but you may be able to keep some specialized equipment up and running using one of these portable systems. These generators can be run for either a short period of time or a long period of time, depending on how much fuel you have available. For example, I have a portable gas engine generator that I can use if I lose power to my home, and our small generator will use about 5 gallons of fuel per day in order to provide me with enough electricity to run most of my lighting and my refrigerator, but it isn't powerful enough to run my air conditioning unit with the smaller portable generator that I have. So, if you have a larger workload power need, you can use a permanently installed generator instead. These permanently installed generators usually make up the backbone of your data center's emergency power architecture. These permanently installed generators rely on either diesel fuel, propane, or other types of natural gas to operate, and these generators tend to be very large and they can power an entire building during a complete power loss event for hours, days, or even weeks at a time, depending on how much fuel your system has in its reserve tanks. These permanently installed generators are directly integrated into your data center's electrical setup, and they're designed to kick in automatically during a power loss event. Battery inverter generators are the third type of generator we have, and they usually rely on large lead-acid batteries, nickel-cadmium batteries, or lithium-ion batteries. These battery inverter generators tend to be quieter and require less maintenance than either the portable gas engine generator or a permanently installed diesel, propane, or natural gas generator. Unfortunately, most battery inverter generators can only provide minimum wattage or provide power for a short duration of time during an outage, so they aren't really designed for prolonged use, and instead they're useful for bridging the gap until a longer-term backup solution like a diesel generator, propane generator, or natural gas generator can be brought online and take over our power supply needs. Fourth, we have power distribution centers. Now, a power distribution center, also known as a PDC, acts as a centralized hub where power is received and then distributed to all of your systems throughout your data center. A power distribution center is not just a massive power strip, though, because it consists of a sophisticated system that uses integrated circuit protection, monitoring, and load balancing to ensure even distribution without overloading any of your circuits. A PDC can also be integrated with large uninterruptible power supplies and large permanently installed generators to ensure a seamless transition to a backup power system anytime you are experiencing a power event that creates a power loss event from your power grid. Now, in order to ensure you have solid power to all of your devices, you're going to need to build your data center with multiple layers of protections and redundancies. Your exact setup is going to be defined by your use case and your budgetary limitations, but most large data centers will use rack-mounted uninterrupted power supplies to be able to provide line conditioning and battery backup functionality to all the servers contained within a given server rack. These batteries are usually going to be sufficient to maintain the power load for all of the servers in a given rack for about 10 to 15 minutes. Your data center should also use power distribution units to perform line conditioning and load balancing to each server rack from your main utility power source, and in the case of a power loss event, the power distribution centers can also receive their power from backup generators if your grid power is lost or unavailable. These generators usually take about 30 to 60 seconds for them to start up, and then once they come up to speed, they'll be ready to start carrying the power load that you need to your power distribution centers. So remember, when it comes to powering your data centers and protecting them against surges, spikes, sags, undervoltage events, and complete power loss events, you can rely on the use of line conditioners, uninterruptible power supplies, generators, or power distribution centers to be able to service all of your various power loads. Line conditioners are devices designed to improve the quality of your power that's being delivered to your electrical load equipment by ensuring a stable voltage supply is being given. An uninterruptible power supply is a device that provides emergency power to a load when its normal input power source will fail. A generator is a machine that converts mechanical energy into electrical energy for use in an external circuit through the process of electromagnetic induction. And power distribution centers are specialized facilities that receive electrical power from a primary source and distribute it to one or more secondary circuits. By understanding their roles and the importance of each, we can better ensure that our digital systems remain online and operational at all times.